Hi, today we are going to talk about how to find limits algebraically. So we're going to take a look at a few methods. The first one is what we call direct substitution. This is when you can actually take a value that you're trying to evaluate the limit around and substitute it into the formula and you will get the answer. So if you look at example 1, we have a continuous function here and we simply substitute 2 into this expression. We're going to get 2 cubed plus 2 times 2 minus 4, and that's going to give us 8. Example 2, we have x minus 1 divided by x squared plus 1. We're trying to find the limit of that when x approaches negative 1. We can substitute negative 1, there is absolutely no issue. It's going to give you 0 over 2, which gives you 0. Sin x over x, the limit of that as x approaches pi over 2. No issue there. We are going to do that. So sine of pi over 2 is 1 over pi over 2. That's going to give you 2 over pi. Example 4, we have limit as x approaches 2 of square root of 2x minus 3. We can do substitution here. There's no problem here. It's going to be square root of 4 minus 3, which is 1. But I do have to warn you about this. If you look at example 5, we're trying to evaluate the limit of square root of 2x minus 4 as x approaches 2. There is actually a problem here. If you do direct substitution, this is going to give you 0, but this limit actually does not exist. The reason it does not exist, when we define limit, we need to make sure that the limit, we can approach the value from both sides, left and right, and this function here, x has to be greater than or equal to 2, and since we cannot approach 2 from the left, we do not have limit here because one-sided limits will not exist. Okay. Now, sometimes the limit does not produce a meaningful result. So if we take a look at example 6, we have this expression x minus 3 over x squared minus 9, and we're trying to find the limit as x approaches 3. So if you substitute 3 into this expression, you are going to get 0 divided by 0. 0 divided by 0 is what we call indeterminate form. Which means we don't know what the outcome is. But algebraically, well, I shouldn't say algebraically, arithmetically it's not going to work, because when you try to evaluate this, this is what you're getting. So we're going to use a method called dividing out. By dividing out, we're going to do the following. We're going to say, okay, if this is what I'm going to have, let me see if I can factor something. The bottom here can be factored, like that. And what I can do after that is I can actually cross out x minus 3. And that is the problem. That's what's causing that 0 divided by 0. So now I'm going to get limit as x approaches 3, or 1 over x plus 3. Now I have no issue. I can use direct substitution, and the answer is 1/6. So same thing over here. If you substitute negative 1, you're going to get 0 divided by 0. So what we are going to do is we are going to factor. So this is x plus 1 times x squared minus x minus 1 divided by x plus 1. X plus 1 can be crossed out. So this becomes the limit as x approaches negative 1 of x squared minus x minus 1. And direct substitution is not an issue anymore. This is negative 1 plus 1. I'm sorry, this is positive 1 plus 1 minus 1, and the answer is 1. Okay. But sometimes you're going to have situations when you have 0 divided by 0, but the expression is not going to be factorable. And when that happens, there's another way to handle that. First of all, when you see this expression, x minus 1 over x square root of x minus 1 as x approaches 1, this is going to be 0 divided by 0. So we have indeterminate form. But these are not polynomials, well, at least the bottom is not, and we can't really factor it. So there's another method that we use called rationalizing. So for that to work, we are going to look at our expression And what I'm going to do is get rid of my square root that I have in the denominator. It may sometimes be in the numerator. What I'm going to do is I'm going to multiply the top and the bottom by the conjugate of the bottom. And what it's going to do, this is going to give you difference of squares. The limit as x approaches 1 of x minus 1 times square root of x plus 1 over, it's the difference of squares, so it's going to be x minus 1. And now x minus 1 on top and x minus 1 on the bottom can cancel. We are going to get the limit as x approaches 1 of square root of x plus 1. And now direct substitution works, and we are going to get 2. Okay? So this is what you do when you have a situation when an expression cannot be factored. This is called rationalizing. Alright, a couple more examples. Example 9, I'm not going to check this. This is 0 divided by 0. So what we're going to do, we're going to go straight to rationalizing. Look at this expression on the bottom, square root of x plus 3 minus 1. So I'm going to multiply the top and the bottom by square root of x plus 3 plus 1. Again, what I'm trying to do is I'm trying to get a difference of two squares. And that's going to give me the limit as x approaches negative 2 of x plus 2 times square root of x plus 3 plus 1 over square root of x plus 3 minus 1 times square root of x plus 3 plus 1. Again, this is difference of two squares. So I'm going to get the limit as x approaches negative 2. The numerator is going to stay the same. It's a little long, but it's okay. Just keep it. This is difference of squares, so it's going to give you x plus 3 minus 1. So this is going to give us the limit as x approaches negative 2, right? We're going to have x plus 2 here times square root of x plus 3 plus 1 over x plus 2. X plus 2 cancels. It's going to give us the limit as x approaches negative 2 of square root of x plus 3 plus 1. And it's going to give us, now we can use direct substitution, that is going to give us 2. Alright. And the last example here, this is slightly different. We do have an expression that involves a complex fraction. It is 0 divided by 0, because you're going to get 1/2 minus 1/2 on top, which is 0, and 6 minus 6 on the bottom. But we're going to do it a little different. So what we're going to do here is we're going to combine these two fractions in the numerator. What I have there is x, 1 over x minus 4 minus 1/2. So if I bring them to a common denominator, so I'm going to multiply these by 2, and this I'm going to multiply by x minus 4. I'm doing this separately, I'll come back to the original problem. So this is going to be 2 minus x minus 4 over 2 times x minus 4, and it's going to end up giving me x minus, 6 minus x divided by 2 times x minus 4. So let's come back to the original problem. We have the limit as x approaches 6. So we're going to have 6 minus x over 2 times x minus 4 all over x minus 6. So if I simplify this, because it's a complex fraction, and reduce it to a regular fraction, I'm going to have 6 minus x in the numerator over x minus 6 times 2 times x minus 4. These two things, x minus 6 and 6 minus x, can cancel with a negative 1, because they're opposites of each other, right? So that means we are going to get limit as x approaches 6 of negative 1 over 2 times x minus 4. Direct substitution works now. You have no issues anymore. So it is going to be negative 1 divided by 2 times 2, and the answer is negative 1/4. And that's how it's done. So I hope this helps. If you have any questions, let me know.